Well, now for number 3, we're given the question, what pattern do you observe when you compare the two columns of y values, and when you reflect the graph across the x-axis, what happens to the y-coordinates? Now I've got a little chart for us over here that basically labels the x values. It's got a YA column, and what the YA column represents is the y values from graph A, and the YB column represents the y values from graph B. Now if we look at what pattern we observe when we compare the two, I notice right off the bat we've got very similar numbers in here. Like here we've got 4, we've got negative 4 for x equals negative 2. When x is negative 1, we've got 1 and negative 1. When x is 0, we're still at the origin with a y value of 0. When x is 1, we've got 1 for graph A, negative 1 for graph B. For x equals 2, we've got 4 and negative 4 for graph B. What I've noticed is that basically, again, when we get the same number, we get the negative of that number when we look at the B values. So our y values for graph A, the reflection is a negative y value in graph B. This kind of answers the second part too. So basically what happens to the y values is they become negative. Again, we haven't found out our values for 3 because it was off the graph, but we can actually find that out very shortly. When we move on to question 4, the equation of the graph A is f of x equals x squared. Now we need to find out the equation for graph B. To do this, we can kind of use what we've already learned from question 3 and 2. We can look at, okay, well, graph A is f of x, and graph B is g of x. Well, what we've noticed is our y values become negative. So we can almost look at it as g of x equals negative of whatever we get out for our f of x when it's reflected over the x-axis. So what that gives us then is we've got g of x equals negative x squared, since we know what f of x is. So we can go ahead and fill this out, and g of x is negative x squared. And we can actually use that now to figure out what we needed for our x values in 3. Again, f of x is x squared, so f of 3 equals 3 squared, which is 9. And for g of x, or excuse me, g of 3, that's negative 3 squared, which is negative 9. So we can actually come up to our column here, and we can enter in 9 and negative 9. If we wanted to go back and check to make sure that works, all of the graph A ones work. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Now if we look at our column B, since it's negative of x squared, again we've got negative 2 squared would be 4, and the negative of that would be negative 4. Negative 1 squared would be 1, but the negative of that would be negative 1. 0 squared is 0, the negative of 0 is just 0, so we can keep our 0 in there. When x is 1, when we square that we get 1, but then the negative ends up being negative 1. When we square 2 we get 4, and the negative is negative 4. When we square 3 we get 9, and the negative of 9 is negative 9. So it looks like our g of x being negative x squared is matching up. When the graph of y equals f of x reflects across the x-axis, how does the equation change? We've kind of already answered that. We've found that basically when we have our f of x, when we reflect it over the x-axis, we get our reflection, which is g of x, which basically is again negative of our f of x. Now hopefully that was fun and easy for you today. If you need any other help, again there's the website. Also too, you'll have plenty of fun in class, and you can always check out more videos. Have a nice day.